Okay. Anyone who had questions in the chat, can you retype them? Because I can't see the chat anymore. I mean, like the chat from before I popped off, disconnected. Why do you use win counter +1? Well, each time, I'm going to pull up the MATLAB for reference as I'm answering this. Okay. So win counter equals win counter +1. This is a common when you're using like for loops and you're trying to count something. You're trying to count the number of wins. So let's say we run this once. This is the first simulation. Win counter is equal to 0, and we lose. So it loops through this, and we do nothing. But if we win, then we add 1 to the win counter. So win counter equals win counter +1 becomes 0. 1 equals 0 plus 1. And we keep doing that. Sometimes this simulation will turn 0. Sometimes it'll return 1. It's kind of like a very complicated Boolean. It generates either 0 or 1. And if it's 1, we win. If it's 0, we lose. And we gather up all those wins. Let's say we win 36 times. Our win counter is 36 at the end of all these simulations. Then 36 divided by 100, we have a win rate of 0.36. That's what that means. This is a very useful structure, by the way. Like win counter equals win counter +1. You'll see like n equals n plus 1. That's just how you like add. It's like an increment. You count +1.
Dennis, I've got a question.
Good.
So is it kosher in terms of syntax to have like an if else if without like an else as like some kind of catch-all, or like else you get, win counter just equals win counter, or
this is totally fine.
Like,
yeah,
you don't need an else.
Let's see. In this case, I wonder if we changed it to else. So the reason we're not using an else here is that it has to be these two cases. What we could do is we could put an else and then win counter equals 0. In all other cases, no, win counter equals win counter plus 0. We don't want to, yeah. So, but we don't need that, because if our else statements just do nothing, we don't need that.
Okay.
We can totally do this. It's fine if we just have it as self-if.
Yeah, it's awesome.
Okay, let me look in the chat lists to see if I missed anything. Don't see anything. Again, repost any questions you had before my Zoom took a dump. Stop sharing and well, actually, no, I don't need to stop sharing. I'll just like version 19.
Hey, Dennis, is there an error in this code where it says on the else if line, guess is not equal to car?
That's not a typo.
Isn't it guess equal? So it's guess not equal to car? You get a plus win?
Let's see. If we have door number 1, 2, 3, and our guess is 1, and the car is not equal, well, look, let's prove by contradiction. Guess equals car is our code. Now, Monty reveals one of the other doors, and then you decide to change to this one, because our methods change. Then our guess, so this is where the car is, and this is where we are after the change. So we don't win in that case. We need to have the car not be our initial guess so that we'll win after we change. It's the change part that makes the difference.
Okay, yeah, cool. Thank you.
Okay, last call for questions on this one, then we'll move on.
I've got a question. So how are we showing in this code that one of the doors has been taken away?
We don't really need to. I'm sure there's ways to code that, but the reason why we don't need to is there's really only two cases, right? There's stay and change, because we have two different cases for these, right? I mean, it's like two different regions. There's the one we initially picked, and then the 2 that we didn't pick. And I kind of showed a video on Monday by Numberphile that kind of talked about that. The way this problem works is it kind of condenses all of the doors you didn't pick. Let's say we had like 4 or 5 doors. Let's say we had 5 doors. Then we had like 4 we didn't pick. Then all of these would be like either you picked the car or you didn't pick the car. In which case, like if you didn't pick the car, Monty's going to reveal like a bunch of these, and then like maybe this is the car, right? The car is here. So you either stick with your original thing, yes, I picked the car, or if I didn't pick the car, then that means if I switch, I'm guaranteed to win.
Okay. Cool.
Okay. Going once, going twice, we can move to Sudoku. Okay. It's not pronounced Sudoku, as some pronounce it. Sudoku solver. Oh, this is a very meaty code. Oh boy, I can't fit all this. How do I want to do this? I'll show it in 2 segments, I guess. I'll just start up here. Start from the top, why not? Annotation, let's stick with red. I like red. Nah, let's be patriotic here. Blue. So what does this one do? So grid output. This is another initialization. It's kind of like the my new car case with the win counter equals 0. We're just kind of like initializing so that once we call grid out, then we're pre-allocating an empty grid. That's what it's doing. So let me find. I'll just shade this in. Pretend this is like a 9x9 board, Sudoku grid. We'll start with that. Very first step. So while what this means is grid out not equal to grid. So long as, let's see. First of all, the reason why we need to do any, right? So any is like if I recall, there's not any if any of them are non-zero, I believe, because this is going to generate an array of, no, not an array, but in this case, a matrix of Booleans. So it's going to be, if this were like 3, 3, I don't know, 3, 4, 5, ... and do 4, 3, 5, it's going to be, well, in this case, it's all going to be 0. 0, 0, 0 is going to be the Boolean array when we compare these two. If this were an equals equals, in this case, we have a not equals, so this actually be 1, 1, 1. And any is, okay, let's see what they're doing here, actually. So any, grid out, not equal to grid. So we have a grid input, and it's got some empty spaces in it. Let's say it's this. So let's say it's mostly filled in, but with a few empty spaces here, here, wherever in the Sudoku grid. So while any of the grid out is not equal to grid, so grid out, we're going to take this. We're going to take this empty array, and we're going to compare it to this grid over here. So while the grid is, why am I having such a hard time understanding this? Hold on. Because -1 times 1's 9, 9. We have an array of -1s because you can't have anything with -1s in the Sudoku puzzle. So it's basically, wait a minute. I'm not sure why they're doing this, actually. Can we come back to this? I'll explain this later. So I was talking on Monday when I was talking about the skeleton code. I'll scroll down a little bit if I can clear some of this. We have the 3 checks that check for rows, tool, rows, columns, and the grid. That's the 3 basic rules of Sudoku. So each of these has a basic format because they're all essentially the same rule but a different application. You check a row, you check a column, or you check a 3x3 box to make sure that that row, column, or box has all numbers from 1 to 9, all integers. And each of these is structured the exact same, with some differences in the grid indexing. The way this is set up is you have a slice. We're going to take a slice out of the grid input. And then we're going to feed that slice into a subfunction that I'm going to show you guys later called fill slice. And it's going to return slice back. And this is going to be either the original slice, or the filled in slice. And it's only going to fill it in if there's one empty space. And there's code that guarantees that. And then of these, you can go there if you want, but like this is just shenanigans with indexing and defining what a grid is, what a row is, what a column is. This. There it is. So what does fill slice do? How do we fill one of these rows, columns, or 3x3 grids? So nempty. So first we take the sum of all of the booleans. Here's another instance of that boolean. So we're taking slice. Let's say we're doing a 3x3 grid, let's say. 3x3 grid and like one empty space. So slice equals 0 is going to tell you where those empty spaces are. So the reason why we need to do sum, right, is because we can have a grid, like a matrix, like 1, 2, 3, blah, 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 blah. The sum only sums in one direction at a time. It's going to sum, I believe, so we'll need to do sum of this in order to compact it twice, like one in each direction. And then once we do that, we'll get a number. And this is the number of empty spaces. Why do we do that? Well, if the number of empty spaces is 1, then we know what number goes in that blank. If there's 2, then if there's 2 empty spaces, we don't know which goes where. You know, if there's 2 empty spaces, 7 and 8 are missing. It could be 8, 7, or it could be 7 and 8. We don't know which one. If it's 0, however, so this is the 2 case. If it's 0, then we're done. If it's 0, we don't need to do anything to this. But in both the 2 and a 0 case, we just spit out the original slice. So if empty 1, we skip this entire if statement if there's not one empty space. If there's 2, 0, if there's 3. But if there is 1, that is, if there's only one empty space, and we know what that is, then we scan over. So there's multiple ways of doing this, by the way. The number, so for the number between 1 and the number of elements in slice. So, okay, this is a bit of a complicated one. If you take any slice equal to number, so you're taking each number in that grid. But let's say there's 1, 2, 3, yada yada. We'll take 1 and we'll plug it in as 1. So if there's, wait, oh no, I'm sorry. This is just the number of elements in that slice. So I think this is just 9 always. What this does is, for a number between 1 and 9, if there is not that number inside that grid, then wherever your slice is equal to 0, you plug in that number. So what you're doing here is you're taking this empty space and let's say this is empty. I'm going to erase this part. You're taking that number and you're filling it in. 1's missing, or 7's missing, or 8's missing. Whatever is missing from that grid. So looking at this, I'm thinking it has to be equal to 0 to be empty. Let me check that line above here that I was stumped on at the beginning. In my mind, you're creating I see what they're doing. They need to distinct. The reason they're doing -1 is you want to have. This is your output, and it's filled with -1s. And then you want to convert all of those -1s into some number. -1's kind of like an empty space in the output. Grid out. And this is grid. So while any in grid out is not equal to grid, then you want to now, you know what? Let's discuss. What do you think this line does? What do you think this does in terms of like this while statement? Let's figure this out together. And let's simplify this actually. Let's assume that grid out is just like a 3x3. Let's just work with like a very easy Sudoku puzzle. This is going to be -1 dot 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 dot. 1, 2, 4, 5, 6, 7, 8, 9. And let me check the PDF actually, because I think they define the what do you call it? An empty space. I want to see if they define that as 0. If someone already has it open, they can check as well. Okay, so 0 indicates a blank space in the puzzle. So then let's say this is a 0 that's dictating the empty space. While any grid out is not equal to grid. So currently, this is true, right? All these are filled out. What I'm wondering is, once this thing's filled out, then if this is 1, 2, 3, 4, 5, 6, 7, 8, 9, this is not going to be equal to 0, to my understanding, unless we're oh, I see what they're doing, because they reassign what grid is. For example, here, Wait, did I accidentally do something? I think I accidentally deleted part of it. Okay, there we go. Sanity restored. We reassign what grid is, so this becomes 3, for example, once we run this, one of these 4 statements. And I want to see where they put in grid out. Okay, grid out equals grid, that's where it is. So while this is like -1 ... The first time we run this, we're going to allocate grid out. Okay, I'm on track now. The first time we run this, I'll make some more space. 1, 2, 0, ... 1, 2, 0, ... That's the first time we run this, first while. And after that, this is going to turn to 3. This grid. This is grid. This is G out. And then it's going to assign grid out to grid. Well, it's going to assign grid to grid out, I should say. So after we'll need to run it actually a second time to fully fill this out. Second while. Then after that, it'll stop and then we'll be done. It'll terminate the loop after that second while. That's just a simple case of like a very simple 3x3 Sudoku, but it extends to 9x9. Note the process that I kind of used to work through that problem. If I can't fully wrap my head around a 9x9, I simplify the problem to like a simpler one, like a 2x2, 3x3 matrix, because it works just the same. The format of this works with any size Sudoku puzzle. I mean, it's not going to be able to solve like super complex ones, but the idea is there.
Dennis?
Go ahead.
So where it says fill slice, where is that subfunction?
It's underneath all of this. So
okay. I don't think I've actually used a subfunction.
You just it's fine if you just do this in every single part of this. It's repeated code. Let me clear my drawings. It's in the recording. If you want to put this part under here, you're totally fine. I mean, it's just repeated, that part of it.
Okay. And is there another technical term for subfunction? Is it like anonymous function or something like that? Or
anonymous function is something different. Subfunction, okay. I think, is the official term. Anonymous function is something like where you say, I'm going to define anon equals, let me remember the syntax for this. At whatever variable you have that you want to have as a variable, and then 2x. 2x. Times. Excuse me. Rookie mistake. Okay, we've made a function called anon. It's an anonymous function. So anon x. Another rookie mistake. Anon 2. There we go. We multiplied it we multiplied 2 by 2 and we got 4. So we can just use one line and define a function like that, if we so desire.
That's right. Nice.
The other term for a subfunction, Cam, is a nested function. That is a function within a function. Actually, they're not exactly the same.
I think that's within the same end statement, right? You need to do this.
Exactly. That's the difference. A nested function is within the end statements of the main function. So they are kind of similar. They're not exactly the same, but those are very similar concepts, and you might have heard it too.
Sub means underneath. So if it's underneath the function, it's a sub. If it's nested, it's like inside the function. So the thing I did here is that I put the end for the initial function, my Sudoku solver, at the very end. So it kind of Matryoshka dolls this whole thing inside it. But if I don't want that to be the case, I just do this.
Just as a parenthesis, the difference between those two is that a subfunction is not different from any other function. It's just another function that is there, you can call it from your main function. A nested function that is inside your main function, those two share the same workspace. So that's something very interesting that you, for instance, if you have defined in line 6, we define the variable grid out. Within a nested function, you could use grid out without passing it as an input. They share the same function and they can see the same variables. So that's something to be careful with in case you don't want that to happen. But it is also something that you can make use of in the cases when you are, especially in the cases when you are calling a function several thousands of times, like for something that's recursive, because that can give you some computational advantage in the sense that every time of the thousands and thousands of times that you call that function, your computer doesn't need to create these variables every single time and find a piece of memory to assign to them. It just looks at the variable that you've already created once. So if you're calling it several thousands of times, it is faster to let your functions share a workspace within a nested function. But it's something you need to be careful with, something you need to do on purpose. That's just a parenthesis to have in mind. You don't really need to worry about this in this lab.
There's a question in chat, by the way, about like what a nested function looks like. I'll show you. This is me showing you guys again. Just put the, and Jose will feel to correct me on this, but function end for that function, and then this function is inside that function code zone.
That is right. And if you just to show an example, could you nest it again and write a line inside the function, that the nested function that says I don't know, variable a equals grid out.
Nested function. But repeat what you want me to do.
Something like a equals a grid out.
Is there a yeah? There's an underscore.
Okay, but I think you're outside the end of the nested function, so put it inside the nested function.
Oh, inside. Okay.
So you see how MATLAB highlights that in blue? That means that is a variable that is shared between the main function and the nested function. So that's how you know that you're making use of that ability to share a workspace. So here, grid out was not passed into field slice as an input, and yet it can see the grid out that was defined in the main function. So yeah, I think that's what I wanted to show them.
So once again, this grid out is not going to, like, this is not going to be, this is not fine because it can't see grid out.
Like it wouldn't be in a normal function,
in a nested
but
function,
it is in a nested function.
Makes sense, makes sense.
For sure.
It's tricky. I think in
It's
all
tricky.
the examples you've done in labs, I think subfunctions have been the way to go. You just, if you don't want to go wrong, you just pass it as an input. Slice, comma, grid out. If we ever use that, then yeah.
Yeah, so for this lab, you will probably not need nested functions, but it's good that you know that these exist and that these give you a computational advantage when you are calling your function thousands and thousands of times.
Okay,
Is that for like your structural engineering of simulations? Like you're trying to make sure it's efficient, so it takes as little time as possible.
I
Yeah.
have used it. Yeah, I have used it in a few simulations in structural engineering. It's also very useful in seismic engineering when you want to do a relatively simple calculation, but perhaps a few million times, and you don't want to spend hours and hours just waiting for the result. So yeah, that's a good example.
We kind of talked about the in lecture today, the kind of big O kind of idea. That's pretty relevant in terms of if you're doing a really big code, like you want it to scale well. You want it to, if it's a very big input, you want to be able to solve that within a reasonable amount of time. I mean, I've done code in the past where, like, just because of the scale of the problem and how badly it's scaled, to complete it all, it would take like longer than the universe would take to like burn out the heat out of the universe. So like that's the reason you're kind of talking about big O. You want to be able to solve this and like before you die, basically.
Yeah, and
I'm not
that's
exaggerating. Like that's the time scale
yeah,
sometimes with these problems. You want it to do that.
and that's a really once you get to that point, that's a really fun thing to consider when you're programming. Like when you develop an algorithm that, okay, it works, technically it works, but it's just too slow, so how can I make it better? So that's a very interesting thing to consider when you get to that point. At this point, we should worry more about whether the code works than about the speed of it, but it's a nice problem.
You think about it, but not too hard that it stops being fun. That's my philosophy.
Yeah.
Stuff like this.
Yeah.
We're on a tangent. Does anyone want me to kind of do this? Stop here. Well, I mean, I stopped here. I'll give like 15 seconds so you guys can take a screenshot, and then I'll scroll down a little bit for like the rest of the code. Probably easier in the recording as well. You'll just be able to pause the thing. Okay. Someone posted in the chat.
What's the midterm going to be like? The midterm will basically be like one of these labs. So I think basically we're calling lab 6 a midterm. Will you guys help us? We can give you moral support.
The midterm's just I think, basically another lab, isn't it?
Yeah. How long would it take? I think Dennis, and please correct me if I'm wrong, but I think you'll also have about a week to work on it, like any other lab.
Yeah, my interpretation is just it's basically lab 6. Lab 6 is the midterm. That's my understanding. They're still working on the details, but I mean that's the idea. That's what they're doing. Oh, there's a lot. Oh, there's a lot of stuff in chat actually.
Yeah.
Okay, the midterm's going to be like. I think if it's a lab, we can help them, right? Or let's ask at their next meeting though. Let's confirm.
Yeah. I'm not sure that we will be able to show solutions as right now, or even go through the whole thing conceptually. Yeah, I think we'll have to consult with Professor Lee. How much can we involve ourselves in the problems? Perhaps at a skeleton level, but I'm not sure. We would have to consult with Professor Lee.
There's also another question in chat regarding like can the people just like copy this code? Is that an issue? Because I'm thinking like some of these pieces of code, there's just not too many creative ways you can spin it. You can like change it a little bit, but I mean, if you find a better way to do it, or a way you prefer at least. But like the logic here makes sense for this problem. So
Yeah, I would encourage you to just go through the code and understand how is it working, why is it working. Um, Perhaps there's not a big issue if the code you submit is very similar to this one, but don't. What I'm trying to say is don't blindly type this and forget about it. Like go through it, figure out how and why it works.
one thing I like to do is kind of well, a couple of things actually. One, try to break the code, try and play with it, and see how it changes the code. Like change one number, and then see like where that just messes up the final output. And number two, I'm not sure how many people I went over with this, but there's a debugger function in MATLAB that I really recommend you use, especially when you have loops and if-else trees. I'm going to find a nice little if-else tree over here. For example, if I wanted to go into, by the way, this over here is a stop. Under editor, you can like click run, or I don't know, this is a function, you'd probably best call it in the command window. So if you call this function, right, you type in grid, you feed it some sort of Sudoku puzzle, and then it'll run this code and it'll stop on this line. It'll stop the code. It's not going to run that line. It's going to stop right before it. So you can, at that point, whatever is inside this function, whatever variables you can see, like while this function is running, because normally you wouldn't be able to see it because functions destroy variables after they return their output. They're like, well, we're done. But if you're trying to inspect a function, like just dissect it and see what kind of variables it's using when, this is a really good way of doing it. Let me see if I have here. I can show you one of. I'll do a demonstration with like one of my other codes, I guess. This isn't a E7 solution. This is just one of my homeworks. Where is it? Here, here, and here. Problem 2. Open this up. Okay, this is a bit longer than what we're working on, actually. So let's say I wanted to run this part. And then I want to stop it like this line over here. I'm initializing a bunch of variables, you'll see. Don't worry about what all this means. But I'll click run, change folder, and it'll stop right here. This is what it looks like. This is the debugger. So it's going to stop at this line, and you'll see it's generated all sorts of variables. Nothing underneath it, but it'll stop here. But down here, I also have a function. This is a nested function, by the way. So if I want to stop in the middle of this function, I can click here. I should probably do this. Click here, and then click continue, and it'll go to the next breakpoint. If I'm going to go into the function, I can do this. If I want to go line by line, step, 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 step. Just like that. And it'll continue generating variables over here. Just a quick demonstration of the debugger tool. Use that if you find it helpful. It's a good sanity check, in my opinion.
Yeah, that is a great tool, and I also use that a lot. Whenever I get an error, an error that I really didn't expect about something that I have no idea why it's not working. MATLAB will usually tell you there's an error on line 17, for instance. So I would usually go place a stopper, a breakpoint on line 17, run my code again, and then inspect variable by variable what's happening in that line and why it's breaking down. So that's a really good way to figure out what's wrong with your code.
So how do we, I just tried to do that, but I couldn't figure out how to get into the debug mode. How do we, could you just go over that real quick?
All you do is you place a stop and then you run the code. When it stops, it'll just place you into the debugger.
So what do you, how do you place a stop?
Okay, I think you should quit the debugging and enter it again, just more slowly.
Oh, sure. Problem 2. Thing I'm going to do, I'll just place it on this first line. Place a stop. There's these little lines on the left. I'll click run. And the reason I could click run here, by the way, is even though this is a function, I didn't specify any inputs, so I can just run it. Excuse me. So your question was, how do I get out of the debugging?
Oh, no, actually, it's just, sorry, my script hasn't been saved, I guess, so that's why I can't place the stop.
Yeah, you'll need to do that first. Yeah, because my problem 2 is called problem 2. Yeah.
Yeah.
Also, just
so you place like one at the start and the stop, and it'll just run between those sections,
you can,
or
no, but you could place a few of them. So once you get into the debugging mode, you get into the debugging mode by either running your code or calling your function after you place a few breakpoints. And if you look at the top, you have now the options to continue, to go step by step, and a few other options, and that big stop button at the right. So the step button lets you run one line. You click it again, you run the next line, and so on and so forth, like line by line basis. If you click the continue button, it will run from the current line till the end of the code if there are no other breakpoints, or to the next breakpoint. So if right now Dennis were to click continue, it will run from line 3 through line 8. You see how the green arrow stopped at line 8? That little green arrow is the current line.
I can also step if I want to go line by line, or continue, top to the next breakpoint, or the end, whichever one is the case.
And what I was saying is that, for instance, let's say that we had run this and we got an error at line 14. So we would stop right now at line 14, and we would check whatever's going into that line. So the only variable that's affecting that is variable D. So we would probably check what D looks like. And if there was something wrong with D, then we would know what to fix. So right now D is a scalar, and scalar plus scalar that works. So line 14 should work. So, but if D was some weird value that could not, that was not compatible with whatever you were writing, then you would know what to fix. This lets you inspect variables one by one.
Yeah, question in the chat about question 2. There's a difference between which a field having multiple elements and a structure array having multiple elements. So you'll have in the case that was discussed in chat, you'll have like a 1 by ... This isn't a cell array. It's like it's an array of structure arrays. Like well, okay, it's a structure array with multiple different names, like Joe, Jill, Tanaka, etc. And each of these is going to have a first name, last name, etc. associated with it. But each of them only has one first name, last name. There's only one of them. That looks like indexing. Hold on. Let's try it as like just whatever. These have one element. You get my point. One element. Each of them only has one name, one last name. So if these had, let's say Joe had 2 names, right? 2 first names, then we would have like structure array dot first name dot and index 2. That's his second first name. If we're trying to get, however, the second person and their first name, right here, then that's going to be the second name In this case, it's called name. It's not called s. But this is the way we index that. There's a difference between this, indexing a field, and indexing a structure array. That's the difference. Okay. We have a good amount of time left. I'm gonna check chat, and then afterwards, I'll like share some skeleton code again for whatever questions people want. I think I'll start with 3 since that was requested. So chat. Private message. Join the Discord chat. Quiz 2. Yeah, I'm in the Discord chat. I have the same name, so you'll be able to recognize me. Let's see. I'll keep sharing, but I mean, I'll clear the stuff in. If I can find the annotate. 5, 4, 3, 2, and 1. All right. Let me close this out. And I'll go to the PDF for whatever people want to go over. So let me stop sharing. I'll go to the PDF. Anyone have any other questions that just feel free to chat them out or chat them out. Where is the PDF? Found it. Okay, my majority element. Did anyone have any specific questions on this, or should I just go through the skeleton code again? Okay, I think we'll just do a skeleton code. Majority element of an array. One, 1, 2, 4 versus 1, 1, 2. And this one is majority versus this one, there is no majority. The way we define this problem is majority has to be it's an actual majority, like a 51 out of 100 sort of thing. It can't be exactly half. That's not a majority. Just to reiterate. So the way we want to do this is, so we'll do skeleton code. So I can't show the exact code. The idea is this. I'll pull it up for reference though. So give me about 10 seconds for me to open it on my end. So let's do 2 things first before we loop over anything. First thing we do, and I'll kind of get rid of this first part. So the first thing we'll need to do is assign, we'll need to get like some sort of length of my array to loop over. There's a couple ways of doing this, but this is the way that the solution does it. Number 2, we'll need to pre-allocate majority. A lot of these questions involving loops do this sort of thing where we have to initialize a default value of our output before we loop over anything. In this case, it's going to be nam. If anything is a majority, we're going to put that as the majority output. If not, not a number. That's how we're going to structure this. So we'll have a for loop, and we'll have I equals, we're going to loop over, this is optional, by the way. You could just put this here, like length of MA, like that. Or you could just call this N and then say from 1 to N. One of those ways. Okay. Jose, are you watching the chat, by the way?
Yeah.
Thanks. If I need to take care of anything in chat, just let me know. So the idea behind this is we want to create an array of booleans where we say we loop over every single element. Let's say we have I, and we'll say we'll need to have some sort of code where we say I equals my. We don't need to do this actually. We'll just do m my array. This is going to produce something like, and if we use an example, 1, 1, 2, 3, 1, and we'll pull out the first one for a for loop for I equals 1 to 5, because there's 5 elements in my array. Consistent. Then we're going to say 1, we'll start with 1, equals this big old thing up here. And that's going to spit out 1, 1, 0, 0, 1. Once we do that, once we do all this, then we'll say, okay, let's take the sum of this Boolean array. We'll call it bool A. Assign that to a variable name. If sum of Boolean array is greater than, not greater than or equal to, greater than the length of my array divided by 2, then we'll reassign majority to that number, whatever I is. 1, 2, 3. That's the idea. Whoops. Get rid of this. And let me see if I'll check if I miss anything, but I think that's about all I can say without. Oh, one more thing. Once we do this, we don't want to loop anymore. We don't want to keep doing this and then say, oh, let's check 2. Is that the majority? Oh, it's not the majority? Then, yeah. Well, since we don't need to do anything more, we can insert a function called break. That's going to break the entire loop, and then we're done. We'll just do that and say we have a majority. It's 1, 2, or 3, whatever the majority is. And then we'll be done with that loop. Okay, I'll open it up to questions, and if not, we can go over anything else that people want to discuss. Quizzes or labs, etc. Okay, let's see. Jose been answering in the chat, okay.
There's a question, Dennis, for problem 6, lines 5 and line 36, that I think it would be a great example of how to use the debugging option to check the value of something in the middle of the code.
Sure. So let me just answer this quick question in chat and then.
Yeah.
For that, I'll need to find the make Sudoku thing. Well, let's see. Okay, solid. Okay, stop share, and let's go back to MATLAB. Need about 15 seconds to set everything up, and then we'll be back. Okay, cool, they include it. And share screen, and go back to MATLAB for academic use.
Okay, so if you go to lines, let's see.
Oh, this is the make Sudoku. I'm just like making a random Make Sudoku. Let's see. How many do we want empty? Let's do like 15 maybe. Oh, whoops. Let's not do this. Let's just call the first line. And we'll say, Jose, what's a good seed?
Sorry?
What's a good seed for this? Oh, let me just check the PDF.
Random generation seed. I don't
Does it
remember
say?
actually. Let me check too.
What do they use seed for in this code? RNG seed. Do you guys know like what we're supposed to? Has anyone tried this out? Does one work? Another rookie mistake. I'm not having a good day today. Oh, okay, it works. Solid. I just did the number one. Let's do it.
Okay, that works then.
What do you want me to do? Lines 5, whatever.
Yeah, if you so the question was on line 5, why are we using 2 any's? So so the reason I explained this in the chat, but I'll just say it again. The reason you would need 2 any's is because the inner one, the first any, checks checks your booleans column by column. So it gives you out a row of booleans that is like, is the first column anyone true, is the second column anyone true, and so on. And the second any, the outer any, would check on that row vector. So I think it's a good example of how to, if we put a breakpoint on line 5 and call the function, we could evaluate these arguments within as the code is running.
Oops. This one happens quick. So this compresses it down to a single line. And any. There we go. And that just becomes 1. Because while we're required to true or false. You wanted me to run this?
Yeah, we could call the function and show what the debugger shows us.
Oh, I'm in the wrong folder. Hold on. Up. Labs. Lab 4. All right, we're back online. And we'll call this function. Oh, I need to be in the solutions folder, actually. If I do this, I shouldn't need to show anyone any solutions. There we go. Now I'm in the right folder. Okay.
Okay, so if you see the green arrow, the code stopped at line 5. So we could just evaluate what's happening inside, and we can go from the innermost level outside. So if you copy the part that says grid out is not equal to grid and evaluate it, just so they can see what's going on in here.
Do you want me to step?
No. Just copy the inner argument, grid out equals that exactly. So that gives us a matrix of booleans. So if we click, if we add 1 any, that will check column by column. And we click another any, that gives us a single logical value, which is what we want for a while loop. So that's one way I would use the debugging mode to evaluate my variables from within the code, to check if everything is the right dimension, if everything has values I would expect.
Let's see where this goes. So we're doing rows first. It's gonna go into the first row over here. There's an empty space right over here. What number's missing? It's gonna plug in 9 for that, or it should. So let's go into rows, take a slice, and we'll step. We'll see what that slice is. That's the first line. Let's go to fill slice and feed it. Okay, it already ran it. We just stepped and then we just did that entire function. Let's type in slice again. What's slice now? Perfect. Fill slice did this job, and then it filled in the 9. If we wanted to, we could put another stop right here, and then that would stop in the middle of fill slice. So it wouldn't just do that in one line. We could actually step through this. So now that we're here, we'll continue the for loop. So I mean, we're not going to do this entire thing, but like it's going to step through all of the rows of this. Okay, there's a faster way to do this actually. Press continue. If I want to do all these rows, I'm going to go here. Okay, it's evaluated all the rows. Let's see what grid looks like now. Should be a lot fewer zeros. There's a few left actually. Okay, let's skip column and let's continue. Now what does grid look like? Interesting. Okay, now let's do, so we're at the grid check. We'll just run this one more time, and then we'll be at the final step, and we've completed our first while pass. Grid, whoops, yeah, grid. Okay, I think some of these have been filled out. Like this 0 is no longer this. Yeah, this 0 is no longer this 0. So from here, I'm gonna remove the. No, let's keep these actually. Let's
and if
step.
you go one step, you'll find out that you're still in the while loop.
So we'll keep doing this, and then I'll just remove this. I don't want to do this all again. Continue. After we do a second pass of while, what happens? Do I see any? We have solved the Sudoku puzzle. Sweet. But we need to go through one more to check, and then if grid out equals grid. So we'll need to do another pass, because this is what kind of assigns it to grid out, and then after this, while checks if the Sudoku puzzle is complete. So continue. We're at the end of the while loop. We'll step. Oh, we're done. Okay. So now we finished and we have our grid out, which should be a fully filled out Sudoku puzzle like that. And for anyone who wants to test their own Sudoku puzzle, let's go back to the syntax for that. Little bit. Where did I do that seed? I'll just type it in again, I guess. Where's the make Sudoku? What I just typed in is grid equals, this is how you generate, this should be in your download folder, I believe. You just type in a seed, let's say 1, and then you do the number of spaces you want empty. Don't make this too large, otherwise it's not going to be solvable. If I did like 100, you can't do 100 spaces, there's not 100 in Sudoku. But you want this to be like 15 or so, then you can totally handle it. I've talked a lot about this, so like feel free to ask any questions. We have about half an hour left actually. So
I do encourage you to play a little bit with the debugging function. That's very, very useful to go through a code and see with a microscope what exactly it is doing. So it's a very helpful tool.
what concept is confusing to everyone right now? Wait, Hagen's here. Hey, Hagen.
Hey, Dennis.
Hagen's observing this. I think you got it at 7, right?
Yeah, got on a 7.
Okay. I should probably recap what we're doing. So first of all, we're recording. Say hi, Hagen. That's okay.
That's fine with me.
Sure. What we're doing right now is so first of all to the class. This is Hagen. Yeah, he's a GSI for another class. So we're doing that's him. He has a beautiful face. He We're in the class right now. I think I mentioned this on Monday actually. We're teaching. We're kind of learning how to be better teachers basically. All the GSIs have to take it, and the idea is that by next week we need to like observe and be observed by one other GSI, and they give kind of like pluses and deltas on what they thought of the thing. They only stopped by for an hour though, so that's why he hopped on at 7. And to Hagen, what we're doing right now is we're going over the lab assignment for this week. It's due Friday. There's 6 problems, and some of them are super fun, but the code is a little bit tricky. So we're kind of going over skeleton code / full solutions. Don't worry, the professor authorizes us to show half of these solutions for the lab assignments. It's Professor Lee. He does that. And thank goodness we're using Professor Chow's labs from like spring 2018, and I'm not like hating her on her or anything. For the record, no pun intended. But they're pretty involved, I feel, especially for some beginner programmers. So if anyone in the lab is feeling bad about lab 3, I'll say pardon my language, but yeah, I completely understand. I also realized, Hagen, you watched some of those rookie mistakes I made earlier. I'm good at ESEP. I'm good at MATLAB, I promise. Jose deals with this every single lab. I mean, like, I'm just doing this. He's like, oh.
Yeah, and just for students to have this in mind. Both Dennis and I have been doing this for a few years, and you always make these rookie mistakes, and you there's always sometimes that you are looking at a problem and you stare at a blank page for a few minutes without knowing what to do. So don't despair. That happens to everybody if you find yourselves in that situation. It gets better. It does get better.
If there is ever a case where you like don't know, or just completely stuck and don't know what to do, like number 1, try to ask someone. Number 2, if you need to figure it out by yourself, go do something else, like take a shower, make a sandwich. There's this old story by, I think it was the mathematician like Archimedes. He was trying to like, like the story of like how he figured out water displacement. He was trying to like figure out how much a crown weighed, and he was like sitting in his bathtub, and he's just like, ugh, it's been a long day. And then like the water rises, and he's like, Eureka! I figured out one of the greatest physics problems that physics students across the U.S. now have to face in their AP Physics 1 physics. No, AP Physics 1 I think is what. No, I don't remember. It was a long time ago. But yeah, long story short, take a shower if you're having trouble with anything in life. It'll come to you. Just do something else, like take a break. That's the lesson of it. That's how creative people succeed. Okay, let me check the chat.
I'm gonna go into a breakout room right now, so I'll I'm not sure, Hagen, if you would rather stay in the main room or come into the breakout room.
I think I'm supposed to observe you too, so whatever you guys are doing, I'll just join.
So, okay, so I'll come back to the main room after this.
Someone just privately messaged me in chat. Would you be fine sharing to the room, or So right now I'm the co-host. I'm not sure if I can. If Jose is in the room, yeah, I don't think he can like move me. I mean, like, he doesn't like. What's it called? Yeah, I can't communicate with him right now.
No, so my question was, I just got like a weird error when I did the night question. It said it was out of memory.
Oh, interesting. What was your max turns?
My max, I just used the lab tester and it was 5.
Okay, out of memory.
And I looked at it and it was like pretty much the same as the one that professor showed during lecture, so I'm kind of confused about it.
That, I'm guessing, means it just blew up to such a proportion. It just created so many branches that it exhausted MATLAB. Would you be fine sharing your code?
Yeah, sure.
Let me stop sharing then. I'll if anyone wants to take a last screenshot, or I know it's only half the code, but oh no, this is make Sudoku. Sorry, Sudoku solver. Okay, 5, 4, 3, 2, 1. Go ahead, Serena.
Oops.
Okay, the issue is an infinite recursion, so your thing never stops.
Okay, so how do I fix that?
Max turns equals 0. So let's see. Your max turns should subtract 1 each time you call my knight 2 again. I think the smarter way for me to do this is just let me compare the code, because this is based on what they showed in lecture, so it should be 1 for 1.
Yeah.
All right, so I'm guessing the issue is something to do with max turns and the check for that equaling 0. Okay, let me max. Have we spelled everything correctly? Yep. Else if. Give me like 30 seconds to look at this.
Yeah, no worries.
First of all, you might want to return under the second else if statement. That's probably not the problem, but.
Okay.
Oh wait, that might be the problem actually, because if we move off the board, then try it now actually, because otherwise it makes turns equal to infinity, and then it like exits the if else tree, and then it keeps recurring after that. So if it moves off the board, it can keep moving.
Okay, I'm sorry. Yeah, that was an issue.
Oh, solid.
Okay,
It's always a little thing.
Okay, I'm sorry.
No need to apologize.
I have a question about the last question on the quiz. I chose O parentheses n times log n because that's what the professor said is most efficient in class, but it's wrong.
Best possible time complexity. So best means fastest. Racing algorithm for n elements. Let's draw something on the whiteboard. Because I like this ON problem a lot. Okay, well, what are our options? So let's just do something we're all familiar with, which is, now let's make it bigger. I want to have a lot of different ones on this, like this, like this. This is x. Nah, let's do n. N and then O n. Simple xy graph. So what are the options? We have n squared log n log n, and not sure. I'm not sure how to graph not sure, but we'll do the other four. There's n squared, there's log n, and then there's n log n. Okay, what does n look like? It's going to be this. Nope. Let's do a little shallower like that. This is n. So as we go to infinity, how fast does this rocket skyward? It's considered okay. It's not like horrible and it's not good. Here's n squared. It's like a parabola. N squared. Because like if you think about y equals x squared as a parabola, it's the same thing. Y equals x, well that's just a diagonal. Log n, however, it's going to look something like, let me get this right. It's this. It like starts like this and it tapers off. So this is actually better than n. Because I'm trying to think of an example of this. Divide and conquer, I think. Where you break an array into like different. No, I don't get too technical about this. But like log n's better because as n approaches infinity, O of n, we'll say O of n equals log of n. This is not going to approach infinity that fast. If each of these is like a rocket ship, like this is not getting altitude that fast. The steeper this thing is, the worse the code is, because it just takes forever to run if you're like n2. Like this region over here, I'll use a different color. This is bad. This stuff up here. I think they showed a thing about this in lecture, I believe. Draw. There we go. This is bad. Anything above this line. This over here is good. We'll kind of crosshatch a little bit in the middle with like, this is okay. You can do better than this though, if the problem allows it. Green's good, red's bad. So that's why I think I kind of gave, it's log n. There's also n log n, but I mean, you're multiplying, for n log n, you're multiplying the values of n and log n together. So I mean, if n log n is good, like one of those is better. Go ahead.
That actually also gets on the red region, because at some point you're multiplying a large number by another fairly large number. So it's not as steep as an n squared, but it's still worse than n.
And by the way, there's a way you can tell that this is not as bad as n squared. Here's how you do it. N times n times log n. Log n is better than n. We want log n. We don't want n. So this is always going to be greater than this, which is bad. Because ultimately what this O of n is like time, basically. This is what we can think of it as. This is the time it takes for our code to finish. There's some like really, really nasty ones in this red region that you might see, like n to the power of 3. But like all these polynomial ones, like they're nothing compared to like e to the power of, this is exaggerated, but like e to the power of n, that kind of thing. So like if you do an exponential, any exponential is much worse than any polynomial. N to the power of 1,000. E to the power of n blows that out of the water as you get to infinity. Beware the exponential. And a bunch of other stuff. Oh, n to the power of n. Yikes.
So it's not always easy to calculate exactly the order of your code. But yeah, this is something when you're writing big pieces of code, again, for instance, something that runs millions of times or that solves really, really big problems. This is something that you need to bear in mind. Yeah, because as Dennis said a while ago, if your code will technically work and technically can give you a solution, but it'll take as long as the universe to do that, then it's not good for you.
Okay, thank you. That makes a lot of sense.
Sorry for the long explanation. I'll stop sharing in 5, 4, 3, 2, 1. Did I miss anything in the chat? Nope. Okay, if there's no questions, I'll stand by for next 10 minutes and then wait for people to type in chat or just kind of vocalize. One of those two. At 8, you guys can free to go.
I tried the quiz question again, and it said that the correct answer is ON. I'm not sure why.
For n elements? So did you try n before and then it wasn't n?
No, I didn't try N before.
I think it was said during the lab that that quiz question was wrong.
That makes sense.
Oh, is he gonna fix it then?
Let me
GSI chat.
Yeah, let me text Chao. He's the head GSI. He should be able to fix that problem. If the quiz for some reason was wrong, then don't worry, you'll get those points.
This happens too often.
Yeah, but yeah, sorry about that. Sometimes we do check these quizzes before posting them, but sometimes errors slip by. So we'll try to fix that.
Hey, how are you doing today? Hey.
I'm good. It's been a long day. Woke up. Well, I've had things from 9 until now, and I still have not taken our 244 quiz.
Oh yeah. I'm not doing well on those at all.
Yeah. I always miss a couple things.
Yeah, there's just questions like you guys can hop off early if you already stayed the 2 hours between Monday and Wednesday. Okay, we have a policy where you have to stay for like 2 hours. Technically, like I think we'll make it like 1 hour, 15 minutes, just because like it's like Berkeley time, you know.
Yeah, this is lab.
This is lab. We there are discussions, but I don't have a discussion. Other GSIs have a discussion.
And you guys get a lot of thank yous.
We have a Discord chat. It's amazing. People actually recognize my ReZero profile picture. Oh, so Hagen, you're fine sticking around like a little bit afterwards to kind of debrief, right?
Sure. I feel like I don't have too many comments, but
Sure. I think just like a couple, one or two pluses and deltas.
mhm.
Wait, Jose, are you? Is he also debriefing you, or like? I think you just signed up for me, right?
Sorry.
You just
I
signed
think
up for.
I was signed up for Jose.
Oh, okay. So I think I'll leave you guys to do that then.
Okay.
Sure.
I think someone else is observing me tomorrow. Okay, yeah, I remember now.
Yeah, I actually
Tomorrow?
signed up at 6, but I didn't see the Zoom link until like 6:30. And I was at dinner, so I hopped off.
Yeah.
hopped on
Yeah.
set.
I actually that's on me actually. I didn't see your email until we were already on the lab.
It's fine. I was free at 7 to 8 also, so
That's good.
You're pointing like that way, and then like Jose, like right here on my screen, Jose, and then you're right here.
yeah, I forgot they're different for everybody.
Just
Jose
show me
right
some
here.
direction, and I'll know what you mean.
You're right here for me.
Which was the quiz question that was wrong?
The quiz
Big O.
11, question 4.
That's for big O notation, right?
Big O notation, yes.
Number E7. That class was kind of fun, kind of a nightmare.
I took it during the fall, so I never learned Big O notation. I never knew what it was before this class.
Really?
Yeah, I actually also learned big O notation here. Like I had heard of it conceptually before, but I had never seen someone actually calculate it. There's an example of it in the book. Well, there are a few actually. So yeah, that's actually a new concept for me.
It's basically like the concept of convergence versus divergence, like you learn in 1B, that kind of thing.
Yeah, it's very similar.
It's kind of tied to the PNP problem in like complexity theory.
The what?
It's one of the Millennium Prize problems. Like it's like one of the great unsolved like mathematical problems or something of like the new century. You look it up. It's like it's called P versus NP. There's videos about it. Really, really cool if you want to just burn 10 minutes on YouTube.
I don't really think that I have any questions. I feel like I have a pretty good understanding of what I need to do to finish up. But I joined a little. Well, I joined at Berkeley time. So do I need to stay over a little bit to complete the 2 hours, or is like
No, that's fine. If you don't have any questions, like we are done for today. Yeah, you are free to go.
Okay, sounds good. Awesome. Thank you guys so much. See ya.
Okay, take care.
I think we'll generally be lenient on attendance.
Wait, so students have to stay an hour and 50 minutes?
The policy is 2 hours every single week for each lab assignment.
How is that like verified?
We have a feature in Zoom that lets us track when people enter and when people leave, and then we can just export an Excel file for each of those meetings.
Got it.
It's
So does
we
that mean,
enforce it.
like students like, I don't know what his name was, but he just left.
Jonah?
Yeah. Like, does that mean that him leaving 3 minutes early will mean that he'll only be here for an hour and 47 minutes?
Like I said, we are lenient, and
Got it.
yeah, we'll decide how lenient we want to be, but I mean, like if people are arriving like a few minutes after Berkeley time, I'm not going to penalize them for that. You know, and
Yeah.
besides, people have like midterms and stuff like on Mondays
Yeah,
/ Wednesdays, and then they have to miss.
The idea is for them to attend roughly 2 hours at least.
Yep.
Got it.
Plus, the idea is for these labs to be useful for them to solve out questions and help them solve problems. Like if they don't have any questions or anything to discuss during the lab, then there's no point of keeping them here.
That's true. I mean, it's just like when we had it in person, right?
Yeah.
Yeah. I don't think I was ever forced to stay in my class.
No.
I'm gonna hop off in 10 seconds, so you two can just stay behind. Jose, you're already the host, right?
Yeah.
Cool. All right, I'm gonna hop off in 2, 1. See you guys.
See you.
Yeah.
Peace out.